Again, my name is Patrick Tavares. We're going to talk a little bit about how we leverage machine learning to really drive that application optimization in Kubernetes. And by way of doing that, we're going to show you a little bit deeper dive into the platform, and then I'll actually take you through a demo of Optimize Pro rather. So before I get into it, a little bit more about me. So I'm senior solutions architect here at StormForge. 20 plus years doing IT systems engineering, architecture work. Actually, I'm also a bit of a recovering sales rep for my past days. So based in Dallas, Texas. So, you know, we mentioned if you kind of heard my colleague Rich's presentation, we mentioned that we leverage Kubernetes to do, machine learning to do this optimization in Kubernetes, and our approach to this is really kind of a holistic platform to kind of handle a couple of different ways of kind of how people learn, right? So if you think about we as humans, there's really two main ways that we learn about something, right? We either watch or we do, right? We grew up as kids watching things that took place around us, and we kind of observed that data, took it in, and then kind of made adjustments along the way as we learned how to operate as human beings. Somewhere along the way, we learned that we could actually try things. As a kid, I liked to try lots of things. I like to, jump big ramps with my bike. I like to do all sorts of things. You learn that way too, right? Usually there's a hospital visit involved or something like that. But the point is that they're both pretty effective ways of learning. It just there's a time and place for one usually, and there's a time and place for the other. It turns out that optimization, especially within the context of machine learning, fits that model really well too, right? So if you think about what machine learning does typically is it'll train a model based off of data that's available, and then it'll start making predictions or decisions based off of that data. And the more data that is collected or generated, the more accurate that model can become. From an optimization live perspective, where you've got observation-based optimization, it's pulling data from your observability platform. It's data that already exists. It's generated naturally as part of your application. And so the machine learning model is able to train itself based off of that data. The caveat to that is that you have no control over that data in the sense that you can't affect any change to it. Whereas on the experimentation side, you can actually generate some data by manipulating input values and getting corresponding output values from that, and then see how that input value affected that change, right? Then to kind of round that off, I think if you heard Rich's presentation, we also have, because experimentation requires some sort of a workload to drive that data generation phase of the experiment, typically we'll see performance-based optimization experiments require a load test. And so we provide a performance load testing solution as part of that too, if you don't already have one. So today, and this slide kind of speaks to me near and dear to my heart, because back in my early days of my career, this is exactly how I operated, right? So if I want to optimize an application, first of all, it's usually there's some sort of forcing function that happened, right? My boss came to me and said, hey, we've overrun our costs, or our users are not having a great experience, performance is suffering, go fix it. And so the only tools I had at the time, this was before the days of observability platforms, so I had log files and I had tribal wisdom, right, to kind of figure out how to tune this thing properly. But it was always in a reactive mode. There's a lot of trial and error and manual labor, right? And then the other part of that is that because my boss came to me and told me that I need to be working on this, there's probably a little bit of stress/duress there too, right? So we're under the gun, we got to figure this problem out. And so we'll go through the process of looking at the data, making our best guess on how to fix this problem, push it into production, and then now we wait for the result, right? And I can't think of anything that makes a boss less impatient than when he asks you, hey, is this fixed? And you go, I don't know, we'll see. We have to wait until the result, pans itself out or works itself out in production, right? So the way that we chose to kind of address this from an optimized live perspective is, again, within the production context, is take away that manual, tedious labor part and replace it with an engine that can actually do that on a continual basis, monitoring your observability platform metrics for however you want to configure it, for whatever intervals you want to configure it for, and kind of adjust from a risk tolerance perspective, and then make recommendations based off of the past bit of history on what machine learning has noticed in terms of utilization, right? And so now we have the ability to make a recommendation that can be automatically applied or manually applied, depending on depending on how you would configure it, right? But the idea there is to get something up and running quickly, to take out that automation, or sorry, take out the manual tedium process or tedious process, and just kind of do CPU and memory type of recommendations, because that's usually what you need to do to kind of tweak things along the way in production. So just to kind of recap, optimize live, right? Again, machine learning analysis of your existing data you're already collecting, focus on production environment, recommend those efficient CPU and memory configuration settings based on what we've seen over the past, 2 weeks, 4 weeks, however you configure that, and make the recommendations based off of your risk tolerances, right? So if you're willing to go a little bit higher in risk, you can actually kind of reduce that slack a little bit closer to where the recommendations trail. They mirror the actual utilization curve a lot tighter than if you say, hey, I've got low risk tolerance. Let's give a little bit more breathing room just in case there's some sort of a peak and valley that we didn't account for. So,
question for you.
Sure.
So since you guys are a SaaS-based solution, you have the opportunity to gather data from lots of clients that are sending you lots of telemetry. And I'm assuming it's relatively anonymized when it gets to you, right? So does every customer start off with a blank sheet or are you able to, benefit from the, let's face it, everybody likes to think they're doing something unique. They're not. Applications are kind of the same across the board with some very limited exceptions. So I would imagine that there'd be some good benefit if I'm just starting out and was able to benefit from, let's say building I don't know what kind of algorithms you're using, whether it's linear regression or convolutional neural networks or whatever you're doing. But if there was already a more global set of data in there that I could start out instead of starting from zero,
right,
and having to wait 30 days before or whatever to get really good, data, I could probably, benefit from what the rest of the world is doing.
Right.
You're thinking similar to what Nimble does.
Yes, exactly.
Yeah. So let me take a step back. Point of clarification. So the way that Optimize Live works is that the only data we're sending back to our SaaS-based authentication engine and kind of UI, and which we'll see a little bit later, is it's just recommendations, right? So in that scenario, the recommendation engine lives on-prem because it's got to have direct access to the data. And so I'm sorry, I just looked over there. My connection just kind of bailed on me here. Are we still good? Okay. So the recommendation engine lives close to the data. So that's that data, that metric data is not leaving the premises, right? Now, Optimize Pro is slightly different. We've actually got, I would term it to be a hybrid architecture. So machine learning and the UI and authentication, all that stuff lives in the SaaS. So Optimize Pro, different model, split hybrid architecture, engines up in the cloud, and the experiment control process is happening on premises because it's actually affecting change to your non-prod application, right? So it's doing the heavy lifting in that actual cluster. And the only data that gets sent back is effectively what were my input values and what were my output values, so that machine learning can do the correlation and go, okay, run the next trial with these new values for inputs, right? So, to kind of round out the rest of your question, so yes, we could kind of collect data for kind of shortcutting that process, but what we found was that even though people are have the same types of challenges with applications, every application is still quite a bit of a snowflake, right? It just determines, depends upon your usage pattern. And you might have a different business cycle than even your competitor because you're closing out your books at like an offset quarter year or something like that, right? So there's still enough uniqueness there to where we do start as a clean slate for training the model for each unique application. And one of the side effects is that now the customer doesn't have to worry about their data being used to train the model for somebody else, like a competitor, right? If Pepsi found out that we're using their data to help Coke out, I don't think they'd like it, right? But
you wouldn't even know it's anonymized.
Well, okay. But still. So then how does Optimize Pro work? We kind of touched on this a little bit, but just in gory detail is that Optimize Pro box is effectively a really effective tool in the toolbox of your operations team, your SRE team, right? Now they, with the proper knowledge, they can wield this tool to create an experiment that runs again locally. The Optimize Pro controller will manage that process, kick off initial experiment trial. to get a baseline, and then record the results, send it to machine learning. Machine learning then does its thing and says, okay, let's run the next trial with these new values. So that process repeats until you've exhausted the trials within the experiment. And then at the end, we'll then come back with all the data that's been graphed, and we'll kind of show you that optimal configuration curve and provide you a way to kind of do some of your own deeper analysis within the UI. And then from there, you can actually choose what's most appropriate for your optimization settings, right? So then once you've arrived at your optimal config, the next step is, all right, so great, I've optimized, now what? Well, now our intent is to kind of drive that value further into your software delivery pipeline, right? So now you've achieved that trial that produces the optimal configuration. Now you ship that left in your build pipeline. So now as you do your builds, you're actually ensuring that the optimal performance profile that I want for this application is now being tested every single time from that one trial. And so I can ensure that when this thing makes its way to the other end of the pipeline, it's close to what I expect it to be. If not, maybe we go take a deeper look at what changed and do we need to actually reevaluate that performance?
Yeah, so just a question on the machine, on the process that's running there. I'm curious as to why something sophisticated like machine learning is required compared to something like stepwise linear regression.
So it's a good question. The reason why we leverage machine learning is just purely because of the number of parameters that could potentially be within the field of the experiment, or the number of metrics that you're trying to optimize for, right? It just gets a little bit unwieldy as you increase those number of variables within the experiment, to where we found that machine learning, some of the machine learning algorithms just naturally fit that problem space better than just kind of simple linear regression. And again, to kind of recap, Optimize Pro, it's closer to that scientific approach to learning about your application. Again, kind of the experiment, a scientific approach to an experiment is you really change one variable at a time so that you can effectively determine correlation between what I changed here actually affects the output, right? And so machine learning allows you to do that across way more variables than we could probably juggle in our head. At the end of the day, at the end of the experiment, now you've got that grouping of results that you can pick from that kind of meet your business needs. So,
I guess, what are you really seeing for your customer base with this today? I mean, it seems like it's going to be most useful to those customers that are probably developing their own apps and deploying pretty en masse and in public clouds, I assume is probably a key thing. I guess, can you all speak to that a little bit?
Yeah, so it's important to understand that we don't limit where. It just so happens that there's certain problems that tend that want to be solved for, say, public cloud versus like on-prem, right? Cost versus something tends to be a much higher priority, as you might imagine, for public cloud, right? Whereas on-prem, it might be more around just pure performance, or you may have other types of optimization challenges that you're looking to solve, right? We've been focusing mainly on performance optimization, but when I think of performance optimization, I'm thinking like throughput, I'm thinking versus cost, or like response time, latency, things like that. But maybe you want to have like SLO versus cost, or something higher level business acquisition things like, or business level KPIs like user acquisition, right? Per cost or versus cost, right? If you have a way to capture that metric, and then we have a way to kind of craft an experiment around how we can measure that and how inputs might or may not affect outputs, and then you can craft that experiment and go to work on it. What we're finding is that, to Rich's point from the earlier presentation, was that it's kind of like this 80-20 rule, where the bulk of the applications, we can get to the point where it's good enough with Optimize Live, because we're just kind of tuning things from a CPU and memory perspective with the existing data set that we have. Right now, if we you come to the conclusion that I'm tuning it, I've got the best performance I can get out of the way it's configured today, but it's just not enough, that opens the door to going deeper with an experiment, right? So maybe so we haven't really talked about this, but with Optimize Pro, we can do optimization beyond just CPU and memory, right? If your application pods expose parameters by way of, say, environment variables, or however you're passing these things into your application, we can add those to the scope of parameters by which you can do an experiment, right? So in a Java world, right, garbage collection settings, heap sizes, things of that nature, app developers are supposed to kind of go through that exercise. Most of the time, it's release day tomorrow and we just now got a performance load test done or something like that. So they say, we'll just do that later, having done that myself in the past life. So the experiment allows you to kind of dive deeper. So we don't see them as two separate solutions. It really is one part of the same platform, and they reinforce each other, right? So it may be that you get to a point like we were just talking about where you need to dive deeper. So now you have that option, or you want to make sure that you're migrating this critical app onto Kubernetes, and you want to make sure it's properly architected from the very beginning, in which case you would run that experiment from day one or day zero, right? And plan for it and architect it. Now, let's take a quick look at Optimize Pro. Right, so I think that the question was about using data that exists, Enrico, right?
A combination of the two. So you experiment first, and then you use this as a base for further optimization. So if it's possible to integrate the two models.
Yeah. So today we kind of segregate out the data that's created by normal production loads and the ones that we actually create in a non-prod environment. And the reason for that is that it really kind of it creates that separate space of where we can go and experiment without any type of restriction, and we can effectively create and closely monitor that data that we're creating by way of experiment generation. That's not to say that at some point down the road, maybe we could merge that and try and augment that learning process. But today, it's if it's production level data, Optimize Live just monitors what's already being generated naturally, and then we'll take care of the rest of the non-prod environment with Optimize Pro.
Okay.
Good. So what we're looking at here is our SaaS-based UI, listing out all the experiments that have been run or are currently running. So all of our experiments listed here that have been run in our demo environment. So let's take a quick peek at a Java-based experiment, right? So I'll kind of take you through kind of the high-level basics, right? So at a glance, when you first drill into one of your experiments, you're going to see what our recommended trial is. And again, recommended trial is usually picked from a good balance of the two opposing metrics. In this case, it happened to be trial 59 that we recommend. And we'll show you the number of trials that we ran, and then we'll show you kind of the deltas over your baseline, right? So in our recommended trial, you do take a little bit of a hit in duration performance, but you do gain almost 76% in terms of cost savings from that.
So are you only able to do two metrics at a time in an experiment, or can you do
You can do more than two. What we typically recommend. So we've got this concept of optimizing variables or metrics and non-optimizing metrics, right? And so the ones that will typically establish that trade-off relationship to where we really hammer it and try and optimize against each other, are the ones that are set to be optimizing. And then the rest will just kind of provide collected data based off of the settings from those, the output metric values for those particular metrics.
So you're collecting more metrics, even though those are the two you're focusing on.
You can. In this particular case, we're only collecting two metrics. We're collecting cost and duration. And the problem we're trying to solve is just effectively runtime versus the cost to run that Java app. And then these are the parameters that we're also manipulating, right? So we're looking at CPU and memory for the pod that runs this Java application, but we're also looking at concurrent garbage collection threads, heap size, and parallel garbage collection threads. These are things that are injected into the pod that we want to be able to manipulate, because conceivably that actually makes a difference, not just CPU and memory, but how do I impact the way that the application, the Java JVM runs. So.
Yeah, you do want to be careful that, only those two metrics, causation, correlation, sometimes you can get some false findings.
Exactly, right? And so as human beings, we're really good at finding the false findings, right? But that's where machine learning does a really good job of kind of identifying, and you'll see as we kind of walk through this, you get a sense for where machine learning really found stronger correlation versus weaker correlation, right? So in this case, machine learning did its 80 trials. Each one of these dots, regardless of colors, is plotted here from a trial standpoint. Our blue box here is our baseline, and these are the values. You scroll down there, you click on one, you can see the values of the parameters that were set for that particular trial. And then in a kind of a perfect two metrics that are really trade-offs of each other world, you structure your experiment successfully, you'll usually result in something like this, which is known as kind of a Pareto front, right? It's this concept where machine learning has converged on the frontier of optimal configuration between those two opposing metrics. And now I can no longer go beyond that without, I can't optimize for one anymore without negatively impacting the other. So now I've got that true trade-off going, right? When most people think about trade-offs, they think they have to give something up, which when you get to that point, you absolutely do usually, right? You have to give up one to gain in the other. But what we're finding is that, especially organizations that are kind of lifting and shifting from a virtualized world, most of these organizations really don't have a good foundation for, hey, how do I properly architect my application to land in Kubernetes? Well, in the interest of time, let's just pull what my settings were from my virtual machines. I'll make my containers that size. And so usually you have the blue box way out here on the the top right or wherever, and there's a big delta between where machine learning found to be the optimal configurations and where your application is currently configured. So you get this situation where you can actually get a bit of your cake and eat it too, for a while anyway, until you get to that Pareto front and then figure out what I need to trade off and what my decision needs to be. And so if we go to our recommended trial here, we can see that again, we give up a little bit in duration performance, but we do get quite a significant bit in cost savings. And then here are the values that were used for that one trial, right? And so what's neat about this is with the data here, now, if you're naturally curious, you'll start to ask questions like, all right, so which parameters seem to have the biggest impact on this stuff, right? And so you kind of start clicking through and see what machine learning did with those specific values. And you can see here, just at a quick glance, it looks like machine learning said to achieve those optimal configurations, we really were landing on like 5 or 8 concurrent threads. So now that for me, it causes another question. Like, all right, so let's table that one for right now. I'll kind of click through and we'll come back to the threads. But in my mind, my first go-to would be is CPU, the biggest culprit in performance and dictating performance. And you look here and you can kind of sort of see the beginnings of a curve starting, but it's kind of spread out and dispersed. But I would argue that most of the optimal configuration settings for CPU were centered right here on the 200 millicore, 100 millicore range. And so to me, that tells me that machine learning actually, through its trial and error, had decided that it's actually better to just keep it low, keep the CPU settings low for this particular use case. It doesn't affect it as much in this case, right? Whereas if I click on something like memory, now we're getting somewhere, right? The memory plot looks a lot more like that Pareto front. So to me, that's indicating that machine learning has found that seems to be a much higher correlation of affecting that application performance than, say, CPU did. And so then if I see memory as being one of those bigger impactors, it only stands to reason that heap size is probably tied to that too, because it's a Java application. So now you see that heap size kind of does the same thing.
But Patrick, is that you? Excuse me. Is that you making that assumption by looking at the graphs, or is that the recommendation you're going to get given?
So it's a bit of both, right? So as we take our customers through this and they start to run these experiments, they start to recognize the patterns because there's a bit of observation learning going on there too, right? So you start to see, hey, these are patterns that are starting to form. And so you naturally start to get in tune with seeing these things as you're clicking through it. And then you start to be able to make those assumptions. There's a bit of a learning curve to it, but like anything else in IT, the more you do it, the better you become. And so the patterns will start to emerge from the data, right? Now, from a recommendation standpoint, it's really about, you taking it back to the main graph. You can see from here, these are the recommendations. And then from there, you can drill in and get to those other graphs that kind of show you, whether it's a similar pattern or a dissimilar pattern, right?
Isn't that what we were trying to avoid at the very outset of this discussion?
So
using human views of the data that said what something should or shouldn't look like.
Yes and no, right? So you still, at the end of the day, it's still going to be our job to make a decision of some sort, right? It's just how do we reduce the scope of, because what overwhelms us is too many choices, right? If I go to a restaurant and I've got 30 things to pick from, I'll usually ask the waitress or the waiter, hey, can you just make a recommendation? Because it's usually at the end of the day and I don't want to think anymore, right? But so it's, if you narrow down the scope of your choices, we can deal with that a lot more effectively, right? As human beings, right? So we can get that down to just a couple of decisions that you have to make. It's usually more effective that way. And that's kind of in my mind, the goal of allowing machine learning to get rid of all the heavy lifting and then presenting you with data that you can then make informed decisions.
Does the solution, because I'm seeing a lot of metrics and parameters that you can choose from to go take a look and start to drill down, as Chris is saying. Does the solution advise you as to which of those parameters have the most correlation to optimal recommended impact versus, because,
Yeah.
which of those parameters are going to give you the biggest bang for your change buck?
Yeah. So we do track that internally as to kind of give clues as to how the machine learning model is tracking. It's not exposed here today. But what we kind of work around there is just kind of spending time with the customer, educating them on how to properly build the experiment, one, and then two, like once they get the data back, we can kind of go through and see that, hey, if the patterns look like this is a good indicator that there's strong correlation. If the patterns look like, say, which one was it? I think we're going to look at the next example, right? This one's kind of a bit scattered. The next example will show a bunch of dots all over the place. So there's really very loose correlation, right? And so you can kind of see that just based off of where the data aligns itself to where if it's starting to take some sort of shape, it's got a stronger correlation versus if it's more of a scattered, mess, then it's much looser, if not no correlation. So.
I mean, usually when you're optimizing an application, there's usually one domain that whether it's IO, CPU, whatever, that's always going to be the one, there's no point in fixing the second, third, and fourth, and fifth ones if the first one isn't fixed first.
Right.
So it's fixing the first one first, which is honestly, it's actually all what DevOps is about, right?
Right.
So
but you don't stop there though.
No, you don't stop.
Because then you go to the next one, right?
But doing the next ones don't bring any effect until the first one's done.
Right.
That one's got the kind of order of magnitude effect. So how do we get to the first one?
Yeah. So again, with the way that we would handle that today is to kind of educate you on how to interpret what comes back. And in this case, we would see memory is that culprit. And so what we would then go do is say, all right, so I know that CPU is probably less important here based on the results that came back. So I would I'd run another experiment that's tweaked to where I'm not focusing so much on CPU. I might keep it within a narrow band here. This one's showing a min and max of 200 millicores up to 2000. I'd probably squeeze it into like 200 to 400 millicores, but I would broaden memory now because I know memory is one of the biggest culprits. And I would broaden the scope of heap size settings for experiments or machine learning to actually iterate through and kind of take out other parameters that I know weren't really effective.
So you'd have the non-prod version go and apply these optimizations as another experiment, run it through again, get more data, and then see what you came up with as an optimization.
Yeah, so it's important to keep in mind that Optimize Pro is already in non-prod because we are affecting right. So we would do that within that context. We run an experiment, analyze the data with you, and then you would go and run another one as more questions came up, or as you say, I've identified my bottleneck in my app. Let's restructure a new experiment to kind of dive deeper into that. Because at some point you'll get to the point where you say, all right, it is clearly, we're not handling our memory allocation very well. Let's go talk to the developers because every time I can throw as much memory at this as I want, and it'll continue to improve to certain breakpoint or something like that, and then you can go have that conversation with your developers.
I get the feeling that this is targeted at a certain type of workload.
It's targeted at, again, wherever you are measuring metrics that you can pull out and craft an experiment around and answer a question that you might have in your mind about your workload.
Okay, maybe I should rephrase that, but the fact that you've got workload where you're accepting an extended duration says to me it isn't going to be targeted at workload response time sensitive applications that need to make sure that they're responding to, let's say, like a website, an external stimulus, rather than being a piece of batch work that's going in and actually analyzing some data and producing a result. That's the feeling I get.
Well, so that was that experiment. So to be clear, right? So let me show you another one. In this case, we're talking about a microservice-based web application. And what we care most about this one is throughput. Right. So now we're optimizing for throughput versus cost in this experiment. Again, the recommended trial information and the projected savings over here. But the idea for this one is the axes are totally configurable within the experiment. So that's kind of the first thing that maybe I left out, and I apologize for that. So you can define that to mean whatever you want, right? So in our case, we're defining cost to mean how much our estimated cost of CPU plus memory is together, right? And throughput in this case is just measured in IOPS from across in aggregate across all the pods that make up this application, right? And so in this example, we have 4 pods, so 4 microservices. We've got a DB, we've got a caching service, we've got a worker, and then kind of a voting front end. So there's all these components that are working in tandem. And so in this in this experiment, we're trying to ask the question of how do I balance my throughput versus cost, right? And so for that one, you would tune things a little bit differently. In this case, we're not doing any internal pod parameters. We're just focusing mainly on CPU and memory. With some of the front end stuff that scales out, we're also throwing in replica in there for machine learning to play around with too, right?
Well, for example, in that example you've got there, if I was using the Redis component as maybe my basket in an online shopping environment, you could tune that and say that's more important. So I want to make sure that that gets a good response time all the time, but I don't mind if the rest of it suffers a little bit because that's just people searching and looking at stuff. So their response coming back slower is more important to me. Is that what it's less important? Is that what you're implying?
You can. What this experiment's doing is kind of a higher level picture of the application system of microservices. But let's say that you were curious as how is Redis impacting my total throughput of the system? So if I click here, I see that CPU, it tends to be clustered right over here, right? So Redis CPU seems to be important, but only within a very narrow band of the range, right? So I don't really see that curve yet. It's starting to sort of form. So in my mind, I'm thinking that's kind of a weak correlation to total throughput of the system. But let's take a look at the memory and see, right? Does memory have anything in here? Memory is all over the place on this one. So it seems that the Redis memory setting doesn't really have any correlation to total throughput, at least not yet, because we haven't removed all the bottlenecks ahead of it, right? Because there's always going to be a bottleneck somewhere, right? So in this scenario, I probably wouldn't pick the Redis piece to go dive deeper on. But if, say, I was looking through this and I saw that voting CPU or worker CPU, those are starting to form closer to the curves, right? That we saw the Pareto front. If I go to voting memory, it's kind of a similar thing. There's more of a curve there. So I would focus in on that one, and I might eliminate all the rest of the microservices and just devise an experiment just around trying to tune that. Right? This could be a Java app. I might want to expose those parameters for garbage collection settings and heap size allocation, all that stuff. It may be some other type of app where those parameters are exposed, and now I want to actually dive deeper on them.
So how are customers then translating that to, say, user experience, where, that's obviously a web app. So, looking at user experience and saying this isn't right. Other customers who are doing that, where they're looking at, feedback from people using the actual application at the front end, who are then coming and saying, this isn't as good as it could be. And then you're looking at how you can tune it here, even if that isn't necessarily optimizing for cost,
right?
It's optimizing for experience, if you know what I mean. Yeah.
So it's a good question. It's important to understand that none of this can be done in a vacuum, right? So there's still a lot of things that are in flux, right? You still need someone who, maybe a product owner, who understands the dynamics of their application, where their current pinch points are, so they already have a good idea of where things fail or that sort of thing. And so you can devise the experiments around that. But you still kind of have to have that external, cooperation so that you can actually figure out how to properly bake in that thought or that sentiment into the experiment. Does that make sense?
Yeah, absolutely. Yeah.
So you've got a two-dimensional frontier on here. Are you able to show optimizations for more dimensions than that? Because some of what we're talking about here sounds like I'm actually trying to optimize on 3 or 4 dimensions. And
right.
You were saying before that that's why we need machine learning.
Right. So from a visualization standpoint, that can get a little hairy.
Yes.
So
I was wondering if that's just because you're trying to draw a 2x2.
Right. So it is possible to, we've been switching parameter settings here to kind of change the way the graph is reflected. The same thing can be done if we had more than 2 metrics here, right? So you could effectively do the same type of analysis, but you still, today, the way the system works is kind of keeping it to the 2-dimensional, just because it's easier for us to visualize. Right. And it's in internal discussions where we're trying to figure out the best way to represent those multidimensional, or maybe guide you towards how you might effectively analyze the data set coming back from a multidimensional experiment. But today, that's kind of how we're handling it.
Oh, just put 3D goggles on or something and make it swoosh and whoom and.
Now you're talking metaverse stuff, and I don't know. I might be.
Please don't do that.
Yeah.
Since data scientists like to say that all models are wrong, but some are useful, I'm curious, what happens when you have an unexpected spike,
right?
From some, we did all this modeling, which seems marvelous, right?
Right.
We've isolated the key variables, whatever we need to guarantee throughput or cost as we desire. But what happens when, or how useful is either an overfit or underfit? And
Right.
How would you detect that?
Yeah, that's a great question. I don't know that there's any perfect solution for some of those
Right.
the spikes. So in my mind, the way that I would approach that is that we would just take it on the chin on that one and go, all right, this one spiked way
Right.
above where we thought in such a short period of time.
Right.
I'm going to go build an experiment to figure out what went wrong.
Exactly.
Maybe I find out from marketing that I put out a Super Bowl ad and realized that my technical team wasn't ready for that ad.
Yeah.
What if there was a
and
network?
everything goes down?
What if
right?
there's some other like an external network switch, port failure,
Yeah.
some external thing that causes your parameters to go out of whack,
Yeah.
and it has nothing to do with the application. Some external factor has nothing to do with the application itself.
Yeah.
How are you guys going to account for that? I mean, are you guys only going to, especially with the live thing, are you going to basically keep yourself within some safety lanes and say, okay, anything that comes out beyond those, we're going to ignore them as outliers and not going to train on that?
So in terms of like the safety lane, margin of safety, that's really comes down to setting it to what you're most comfortable with, right? And some of this is going to be a little bit of hey, this is my most critical application. I don't know that I want to hug that performance curve as closely as we can, because I want to make sure that in the event that something happens, I can still gracefully recover or minimize the collateral damage, if you will, right?
Exactly.
So some of that is just kind of trial and error still, but again, like in that scenario, I would then be super eager to create an experiment around that. This is the way that I kind of approached it in my past life. The problem was that I would make a mental note of writing this, like let's do an experiment, and never have the time because it was going to take too long to do. Right. Well, now I have a tool that can actually automate that process for me, and so now I can actually try and craft an experiment to do some of this stuff.
And potentially the outlier could actually be something that, whoa, we need to expect this. Like you said, the Super Bowl ad is a perfect example.
Yeah.
Especially if you're deploying whatever streaming content or whatever, and oh my gosh, we're getting really hit, to gather information. And so just so I see the close here is the idea of optimize live would be you could take that, draw that information into pro, right, and run another experiment, right? Because otherwise, is that the intent?
So
not to steal your thunder.
Yeah, potentially, right?
Okay.
At the end of the day, it's all about doing something actionable and effective with that data, right?
Exactly.
And so today they're kind of separate buckets, but at some point it wouldn't be outside the realm of possibility, right?
Really